everyone, I'm Carlo Carpani and I'm at the third year of my PhD and I'm going to present my research titled Effectiveness of Reinforcing Fiber in Core Recycled Asphalt Mixture. Core recycled asphalt mixture are made with aggregates, reclaimed asphalt and/or natural aggregates, water and binder. In particular, the binder is made up of mineral addition and bitumen, that is emulsified bitumen or foamed bitumen. The core recycling techniques lead to several environmental advantages, that is a reduction of atmospheric emission, reduction of waste and the use of virgin aggregates, recovery of up to 100% of the pre-existing road pavements, and better working conditions for workers. But also several disadvantages, and that is poor performance at early times and lower fatigue resistance than the hot mix asphalt. In particular, this research wants to resolve this last problem going to insert synthetic fibers in the mixture. The objectives of the research then is the evaluation of the effect of synthetic fiber on the rheological properties and performance of core recycled asphalt mixture. To obtain this goal, two different fibers quantities was introduced, that is 0.05% and 0.1%, and then compared with the reference without fibers. On these materials were conducted various test types, among which indirect tensile strength modulus and indirect tensile strength, after 3, 7, 14 and 30 days, and then uniaxial cycle compressing test and indirect tensile fatigue test after 30 days, that is the end of the curing time, were conducted. First of all, to realize this mixture, the wrap was corrected with the limestone filler in order to meet the standard limits, and then 2.0% of Portland cement, 4% of SBS-modified bitumen emulsion, 5% of water and fibers were inserted in the mixture. For the sample preparation was used an automatic paddle mixture at 30 rpm, and then the specimens were compacted through shear giratory compactor at 100 or 120 cycles, depending on the test type to be carried out. Let's move on to the result now. During the compaction of each specimen, the SIIV workability parameters was calculated at every cycle. In the middle of the slide, we can see the variation of these parameters. And then the intercept on the y-axis and the slope of the curve, that is the workability, were determined. As is possible to see in the table on the right, the increase of fibers content leads to lower workability. Afterwards, the higher voids were calculated using the geometric method, but excluding the water inside the sample. As is possible to see in the right graph, higher fiber content leads to higher height voids. This slide shows the ITSM value after 3, 7, 14 and 30 days of curing time for each mixture. As is possible to see, the stiffness increases with the curing time. Moreover, the F0.1% material has the lowest stiffness at each curing time, about 20%. Also, observing the ITS result, we can see the same increment during the curing for all the mixture until to our horizontal asymptote. The F0.1% exhibits the lowest strength at each curing time, and finally the standard minimum is satisfied for all the mixture. Let's move to dynamic compressive modulus test result now. On the left we have the complex modulus master curve, and we can observe that F0.05% and REF have a similar stiffness at the various frequencies, all in all. Instead, the F0.1% stiffness is the lowest. On the right, instead, is showed the phase angle master curve, and we can notice that the F0.1% and Ref have higher value than F0.05% at all frequencies or all temperature. Finally, the ITFT results were plotted in this graph. On the left, the initial strain is reported as a function of number of cycles, and instead, on the right, the stress is reported as a function of number of cycles. In particular, it's evident as F0.05% has better fatigue resistance than Ref at any strain level. An increase in fiber contents leads an improvement in fatigue resistance at low strain level, but a worse at high deformation level. However, the F0.1% material has a better performance than the Ref. In conclusion, the insection of the fibers leads to a reduction in the mixture workability and an increase in air voids. The differences are not significant with 0.05% fibers. The insection of 0.05% of fibers does not lead to a variation of ITSM and ITS value. Instead, this value decreases when doubling the fiber content. The master curve results show that F0.05% and Ref have a similar stiffness both at low and high frequencies or temperature, while F0.1% has the lowest stiffness. Moreover, F0.05% has a slightly lower phase angle than the other materials at all frequencies or all temperature. And finally, the ITFT result show that the F0.05% had the best fatigue resistance. Instead, a double fiber content resulted in a worsening of behavior, especially at high-low cycles or low strain. In conclusion, a correct fiber dosage, 0.05%, can lead to a best performance of core recycled asphalt mixture. In particular, these fibers give more ductility at the material. Future works will be done for replace this type of fiber with others cheaper. Thank you for your attention.